What's up, guys? In our chemistry lab, we observed reactions between two aqueous solutions, copper 2 sulfate and potassium hydroxide, in different ratios.
Afterward, we collected the data based on the precipitate heights at the end of the reaction. We utilized stoichiometry, which is a determination of proportions in which elements or compounds react with one another, which stems from the law of conservation of mass, stating matter can't be created or destroyed, and that the total mass of a system remains constant. Within stoichiometry, you will find limiting reactants. A reactant in a chemical reaction is the thing used first, limiting the amount of product that can be made. For example, if your finished product requires 2 nuts and 1 bolt, you start with 3 nuts and 2 bolts. The nuts would be the limiting reactant, and it limits the amount of product that can be made.
Before we started the experiment, we thoroughly cleaned all the glassware with distilled water. Then we began our lab with Mr. Mitchell, who filled 2 burettes, one being filled with 0.2 molar KOH and the other with 0.1 molar CuSO4. Potassium hydroxide appeared as a transparent and colorless liquid, as the copper 2 sulfate appeared transparent with a strong blue coloration. In each test tube, 5 milliliters of CuSO4 was dispensed. We added increasing amounts of KOH from 1 milliliter into the burettes. Our group then added distilled water until each tube reached the amount of 13 milliliters. Once every tube was in equal height, we stirred/mixed each thoroughly. We let our reactant sit for 15 minutes and watched the precipitate form.
For test tubes 1 through 4, our group observed the precipitate to be a light cloudy blue color with a powdery texture, and that there was also a clear liquid that sat on top. In test tubes 5 through 8, the precipitate color darkens to an almost blackish blue color with a clear liquid above. In test tubes 1 through 4, there was a steady increase in precipitate height. In test tubes 5 through 8, there was a large jump in the height of the precipitate, and it seemed to sit at the same height level.
Our results have a direct correlation with the essential question of the lab. Why are precipitate levels off in test tubes 5 through 8? In test tubes 1 through 4, levels gradually increased because we were continuously adding KOH. That told us that KOH was the limiting reactant, and it was controlling the amount of product formed. In test tubes 5 through 8, we were still adding more KOH, but the products were increasing. That is because the ratio of reactants changed, and we could no longer create more product, with the limiting reactant had changed to copper 2 sulfate.
In test tubes 1 through 4, we viewed the precipitate as a light blue powdery substance that we determined to be CuOH2 because of the copper that made the substance blue. The clear liquid with a slight blue tint that sat on top was the KSO4, and the leftover CuSO4 in test tubes 5 through 8 is the appearance of a bluish, greenish precipitate with a completely clear liquid on top that is from the KSO4.
Overall, our lab was successful, but there were times of human error, like when we switched test tubes 3 and 4, our group decided to switch the tubes back in hopes that they were just mixed around in order. Another example of an error was when we forgot to add water before mixing and had to mix again after adding water.
Wait, there's water?